Hey everyone, welcome back. It's me, the part-time economist, and in today's video, I'm going to be showing you how to do a multiple analysis of variance using the R programming language. Now, I will put a timestamp if you just want to jump ahead to the coding, but I actually want to start this video off with a little bit of a review to explain the rationale and the justification why you might want to use a MANOVA. So, when we think about this, let's just think about comparing in general, because what the MANOVA is doing is it's allowing us to compare multiple groups. Now, you're probably saying, hey, wait a minute, that sounds a lot like a t-test. And in a way, it kind of is. If we think about a t-test, right, we are comparing two different groups. So let's suppose I have college freshmen and college seniors, right? And I want to say, is there a difference between the GPA, right, the grade point average, of the average freshman student and the average senior, right? That is a t-test. We are comparing two different groups with respect to one variable. But let's suppose that we don't just have two groups, right? Maybe we have, well, we do have, right, freshmen, sophomores, juniors, and seniors. And what we want to do is we want to say, look, do any of these four groups differ, right? Do any of these four groups differ with respect to GPA? So now we're comparing more than two groups, or two or more, I should say, two or more groups with respect, again, to one variable. Now, what you'll notice with both the t-test and the ANOVA is that we're only focusing on one dependent variable, but that might not be very realistic, right? Maybe we want to compare groups on a composite variable, right? So maybe I don't just compare on the basis of grade point average. Maybe I also compare the student's perceived stress index, right? Or the index of academic engagement, right? You can think of whatever variables, but let's just suppose I want to compare on more than two dependent, or more than one dependent variable. Traditional t-test, ANOVA, they are not going to cut it. So that's where MANOVA comes into play. What a MANOVA does is it allows us to compare two or more groups with respect to more than one dependent variable. So key thing here to remember with the MANOVA, when we are looking at the dependent variable, right, is going to be a continuous variable, right? So grade point average, it can be 3.7, 3.6, 3.5, right? When we are looking at the independent variable, it needs to be categorical, right? So freshman, sophomore, junior, senior, right? Okay, perfect. So let's go ahead. Let's run through the coding of how to do a multiple analysis of variance using the R programming language. So we are going to be working, everything today is base R. You don't need to install any additional packages. We're going to work with the MT cars data set. Now, this is just a data set of cars and their various attributes, right? So how many miles per gallon they get, how many cylinders they have, all of those things, right? Now, remember what I said. We want to compare a more than two or more dependent variables with respect to that one categorical variable. So let's just suppose, as an example, I want to compare and say, look, does the miles per gallon and the horsepower depend, or does it vary with the number of cylinders that the vehicle has? So what we're looking at, we have MPG, miles per gallon, that's already a numeric variable. We're good to go there. We have horsepower, again, a numeric variable. The problem is that cylinder is numeric, so we're going to convert that really quickly to a factor variable. You can see now it's listed as a factor. Now, what we want to do to actually run the ANOVA, you have to remember, when you're doing MANOVA, you are doing a composite dependent variable, right? So we're not just saying, does the cylinder affect horsepower? Does the cylinder affect miles per gallon, right? We're not testing these two independently. We are testing them as a composite variable. So to tell R how to do that, we need to bind those two dependent variables together. So we're going to create a variable. This can be whatever you want. It's simply to store the model output, right? So we're going to create a variable. We are going to assign it. And then what we're going to do, we're going to type MANOVA That's just the command telling R to run a MANOVA. And then we're going to bind the two dependent variables. Now, keep in mind, if we were doing additional dependent variables, we would just separate them with a comma, right? So maybe I'm also doing DRAT, right? I don't know what that means, but let's suppose we wanted it. We separate them by commas, and then we use the squiggly line to indicate the independent variable. So in this example, we're using cylinder, and then we pass in the name of the data set, MT cars, and absolutely nothing happens. Why does nothing happen? Because we just created the model and assigned it to a variable. To see the output, we are going to use the summary command, then pass in the name of our model. And what you'll see is it gives us all of the most essential information, right? So it's giving us the degrees of freedom. It's giving us the approximate F value, the P value. Now, by default, it is going to give us, and I'm going to do my best with the pronunciation, the Pillai test statistic, right? Maybe we don't want that. Maybe we want something else. Well, it gives us additional options as well. So if we want, let's suppose Wilks, right? Let's suppose we want Wilks. All we have to do, we again do summary. We pass in the name of the model. The only difference is we put the name of the test statistic that we want inside of those quotation marks, and it will give us Wilks test statistic instead. Now, you'll notice obviously the p-values, we're rejecting the null under either circumstance, but if your project wants a specific statistic, that's how you do it. Okay, now remember, when we are doing the MANOVA, we are comparing with respect to that composite dependent variable. So all we're doing here, all we're saying is that the composite variable is influenced by this categorical independent variable, right? We can't, just based off the MANOVA, we don't know which variable or if a single variable is significant independently, right? So to do that, we have to extract the sub-ANOVAs. And the way we do that is by going to summary, AOV, and then passing in the name of our model. Now, what that's going to do, it's going to give us the individual ANOVA for each specific variable, right? So we've got here the ANOVA for MPG, right? We see there is a significant difference. We've got the ANOVA for horsepower. Again, we see that there is a significant difference. Now, keep in mind, just because the MANOVA is significant, that doesn't mean that either of the ANOVAs are going to be significant, right? We could have a significant MANOVA, and then we could have one significant ANOVA. We could have no significant ANOVAs. We could have both significant ANOVAs, right? Just keep that in mind. The MANOVA and the independent ANOVAs are two separate tests. It's important to know what you're doing. Okay. Just a couple other things I want to show you. We can pull the coefficients out, we can extract the residuals, and then we can get the fitted values as well. So obviously there's a lot more that you can do with MANOVA. I didn't even talk about validating our assumptions here, right? We want to make sure that we have equality of variances, right? We want to have normality. We want to have all of those traditional assumptions. So it is important to verify those. But again, this video was specifically focused on MANOVA. So I hope you found it useful. As always, thanks so much for watching, and I hope you enjoy the rest of your day.